let's start talking about this bell work. So I have a table. I want to use this table to find my vertex. So I'm thinking about the shape of a parabola. Show me with your hand what a parabola looks like. Yeah, it's either going to go like this, like a U, or it could be reflected upside down like this. So if it's a U shape, when I'm looking at the y values, that would be like tracing along the parabola, I'm either going to notice those y values getting smaller and smaller and smaller and smaller and smaller until they hit the bottom, and then they're going to turn around and start to come back up. Or if it's an upside down parabola, if it opens down, I'm going to notice those y values getting bigger and bigger and bigger and bigger and bigger until they hit the highest point they're going to, the maximum. And then they start to get smaller again. So I'm going to look down this y column. What's the first thing that you notice? We start with a 6, and then does it get bigger or smaller from there? It gets smaller. It went from 6 to 0. What happens after it goes to 0? It goes to -2, so it gets even smaller. What happens after it goes to -2? It goes up to 0. It goes back to 0. It's turned around. So it was going down before. That means it's going to hit a lowest point, a minimum, and then it's going to turn around. What is the lowest, the smallest y value you see? -2. Notice on either side of it, those y values have repeated. It's like a vertex sandwich. You're going to have the same y value on either side with either the lowest or the highest point in between. Here is our vertex. So that tells me my h and my k values. I'm going to use both of those as I write my transformation form. Transformation form is y equals, and then we see our a value after that, but I don't know what the a value is yet. I do know my h and my k values. So what would I have in here with the x? -1. Absolutely correct. So we're going to have a -1 here because this is the opposite of h. And what's going to go back here? -2, -2, yes. That's where our k value goes. So that's most of my transformation form. I just need to figure out what goes in that spot for a. So I'm going to rewrite what I've got over here, y equals. I'm going to put an a in here instead of a question mark. X -1 squared and -2. There are 3 variables in this. There's y, a, and x. But I have a whole table over here full of xy pairs, ordered pairs that are on this parabola. I can pick out any one of those that I want to and substitute them in for the x and the y, and then we can algebraically work backwards to find what a would have to be. I can use any of the points off that table at all except the vertex, because we've already used those 2 numbers. What ordered pair do you guys want to use this morning? Which one off the table do you want to use? 3 and 6. That sounds good. So we're going to use this to find a. So what would I put in the place of the y? 6. So I have 6 equals a, and then what are we putting in the place of the x? 3. -1 squared -2. Order of operations says parentheses first, right? Can I actually simplify inside those parentheses? Do you know what 3 minus 1 would give you? 2. So inside my parentheses, I have a 2. I'm going to recopy everything else. After parentheses, what does order of operations say to do? Exponents next. We have an exponent. What is 2 squared? 4. So I have 6 equals a times 4. That's the same thing as 4a minus 2. What should I do next as I try to get the a all by itself? Very close. I got to do something else first, but then I will. It's got a minus 2 right here. I want it to cancel. Yes, we're going to add 2 on either side. So I have 8 equals 4a, and now we're going to divide to get the a all alone. So what is our a value then? A is 2. So I'm going to put that in the place of this question mark. So I would have y equals 2, and then inside parentheses, x minus 1 squared minus 2. So there's my vertex form, my transformation form. The axis of symmetry has to go through what part of the parabola? Has to go through the x-axis, has to go through the vertex. So my equation for the axis of symmetry has to explain all of that. What's it going to start with? It's going to start with x. So I have x equals what? 1. It has to go through the x part of the ordered pair from my vertex. It will always be x equals whatever my h value is. Roots. Almost done with this. What do we mean by roots? What am I looking for? The x-intercepts. How would I know, looking at the table, whether or not I've found any x-intercepts? Yes, x-intercepts. This is where y equals 0 on the table. Do you guys see zeros at all in the y column? 0, 0, and 2, 0. Absolutely. These are roots. So 0, 0, and 2, 0. Or depending on how they're asking for it, you could say x equals 0 and x equals 2, because the y part of the ordered pair is always a 0. So sometimes we write our roots as x equals, so that I know where they are on the x-axis. Last thing we need to do is factored form. We're going to use the a that we found before. So I'm going to have y equals, my a value goes first, and then we're going to have our factors. I use my roots to find the factors. Factors always have to be equal to what? 0. This one is equal to 0 already. That means that this right here is a factor. So that's what I would have right next to the 2. For the other root, x equals 2, that one's not equal to 0. What do I need to do to it to get it equal to 0? We're going to subtract 2 on both sides. And so I have x minus 2 equals 0. Now it's equal to 0. That means this part right here, the x minus 2, is my factor. So I'm going to put that inside parentheses. x minus 2. That is my factored form. We've been working a lot with different forms of quadratic equations. We've talked about the three forms: standard form, also called general form, vertex form, and factored form. In our very first unit, we talked about how to go from standard form, that's our ABC form, into factored form. That's where we pull out our GCF and we draw our box and we make our x. That's how we go into factored form. And then we've spent the last several days practicing going from factored form or from vertex form and fully simplifying that to get our general form. There's one more thing that we need to talk about, and we're going to cover that today and tomorrow. And that's how to go from general form into vertex form. So flip in your books to page 81 for me. The process that we're going to use to go from general form into vertex form is called completing the square. When we complete the square, I'm going to use an area model that's really similar to when we factor. But when we factor and I draw my area model, I draw my box, I just draw a rectangle and it doesn't really matter what shape it is. This one is specifically a square. How is a square different than a rectangle? All sides are the same. So this side right here and this side right here are going to be the same. And then I think about my form all along the way, too. So there's my vertex form. When I'm looking at vertex form, I see that I have parentheses that are squared. That's where this square comes in. And I see that it has this k value out behind it that's not part of the parentheses that are squared, so it wouldn't be part of this square here. To start putting it in that form, I'm going to write my original equation in this box. They gave us one to start with here. So y equals x squared plus 6x plus 11. And I'm going to put parentheses around the a and the b values. These two right here. Here's my A, my B, and my C. I'm on purpose leaving C out. And now I'm going to do my best to draw a square right down here. Should have 4 equal sides. The A value goes in the upper left corner. The C value goes outside behind the square. So far, so good? In these two squares right here, we're going to take our B value and we're going to cut it in half. What's my B value here? My B value is 6. So I'm going to take the 6 and I'm going to cut it in half. What do you get when you take 6 and cut it in half? Yes, we get 3x. That's what's going to go here and what's going to go here. 3x and 3x. That's really small. Let me make that all a little bit bigger. I'm going to have to redraw my arrows, but at least you'll be able to see the numbers better. All right. There we go. I want you to look at all the numbers that I have. I've arranged things a little bit strangely, but if I combine the pieces inside the square and this plus 11 on the outside, do I get exactly what I started off with? Yep, there's my x squared. 3x and 3x together give me 6x, and there's my 11. I have not changed this equation at all. It's really important that we not change it at all. We want it to be in a different form, but we don't want it to be a different equation. Yes, ma'am?
So if it's an odd number?
If it's an odd number, then you're going to end up with a decimal or a fraction there. But we would still move forward. Yes?
So what we do is,
I'm sorry, one more time. Yeah, so it's always going to be, are you talking about those two circled boxes? It's always going to be half of whatever your b value is. Every single time. You're going to take whatever your b is, cut it in half, and put an equal amount in each side. Because remember, we want a square. We want our sides to be the same. So it's really important that these two are the exact same value. Good questions. All right, I'm going to redraw this down below since I've got a lot going on in that upper picture. All right, so we have our x squared here. I have 3x and 3x, and I've got that plus 11 on the back side. We're gonna figure out what goes down here. When I look at these two boxes, I notice that they have something in common that would tell me how big the side is. What do x squared and 3x have in common? They have an x in common. What about these two, x squared and 3x going this way? They have an x in common. And now I want to know what would go right here. Whatever goes there, I would take x and I would multiply it with that to get 3x. 3 goes there, yes. So I'm going to have a 3 on the outside. Oops, this is not what I wanted to do. So I'm going to have a 3 there. And because this is a square, what do you know would have to go on the other side? 3 would also have to go there. These are going to be positive 3s. We doing good so far? Please tell me if I do anything that confuses you. This square down here, we need to fill that in. But whatever I put in there, if I add something new to my equation, I'm going to have to take it back away again so that I don't change this equation. So whatever I add, I'm going to have to take away. To find what goes in that box down there, I'm going to take this number and I'm going to multiply them together. So I do 3 times 3. What would that give me? 9. That's what I have to take back away. Whatever I add, I have to subtract again. We are pretty much done with this process. Now we just need to bring it all together. So on either side of my square, I have x plus 3 and x plus 3. What's a better way to write that?
X plus 3 to the power of 2.
Yep, x plus 3 squared, x plus 3 to the power of 2. And then out behind it, we had plus 11 and minus 9. I'm going to combine those two together and get what? 2 plus 2. That is my vertex form right there. Looking at it like this, can you tell me what our h and k values are?
H is 3, K is 2.
Very close. K is 2. H got you though.
Negative.
-3. So can you tell me where the vertex is then?
-3, 2.
Yep, -3, 2. How would you describe this transformation from the parent? Which way did it shift? Left 3. What else? Up 2. What's our A value here?
Nothing.
Nothing. It's a 1 out in front. Whenever you don't see a number after the equal sign, it is a 1, and it does not affect our transformation at all. I want to practice this process a couple more times. We're going to do 2 more together, and then you guys are going to try one on your own to see how you're doing with the process. So down at the bottom of page 81, there are 3 practice problems down there. Let's go look at those. First thing I want to do is to put parentheses around which 2 pieces? The A and the B. Put parentheses around your A and your B values. The A and the B values are going to be used inside the square. C is not. So plus 13, I just bring straight down here. X squared, my A value, goes right in that box. What do I put in these 2 boxes? -4. Just -4? Yes. -4x. That's what goes here and here. So I'm going to rewrite that so that I don't have too much going on. I usually don't draw more than 1 box, more than 1 square. But when I'm teaching it, I want you guys to be able to see my process here. All right, I need to figure out what's going to go here and here. What can I take out of x squared and -4x? I can take an x out. Same thing this direction, x squared and -4x. I can take an x out. What would have to go right here? Remember, I'm going to take x and multiply it to this to get this. -4. Has to be the same on both sides because this is a square. If it's not the same on both sides, then you have not completed a square. To figure out what goes down here, what numbers do I multiply together? -4 and -4. That would give me what? 16. This is the first time I'm putting something new into the equation. I'm adding a 16 here, so I have to subtract that 16 back out again. All right, time to write my vertex form. What do I have inside the parentheses that will be squared? X minus 4, that's the sides of my square. And then to get my k value, I'm going to combine these 2 like terms together. Yep, -3 when I combine those. So I have -3 on the back.
Are you ever going to have an A in this situation?
Yes, but we're going to talk about that tomorrow. We're just going to practice this part right now, and tomorrow we will address when A is not 1. Good question. Where is our vertex? -4 and -3. Because remember, this is the opposite of h, And here's my k. How would you describe this transformation using words? Right 4, down 3. Beautiful. Let's try one more together, and then you guys will do number 3 on your own. So on number 2, parentheses go around which pieces? Yep, x squared plus 6x. Those are going to be the parts inside my square. And the minus 2 goes out at the back. I know x squared goes here, but then I don't put 6x inside my square. What do I have to do with it first? Break it down, cut it in half so that it's the same on both sides. So 3x, 3x, and 3x. Tell me how big the sides of my square are going to be. So here and here. What numbers will I have? What variables will I have? X, and I'm sorry, I didn't hear the other piece.
3.
X and 3, positive or negative 3? Positive. And because it's a square, it has to be exactly the same on the other side. If it's not exactly the same, you don't have a square. So what would go down here? 9. We do 3 times 3 to get this. I'm adding that to my equation, so I have to subtract it back out again. We always subtract from the end whatever we added in that lower right corner. So help me write the vertex form here. This is y equals x plus 3, squared. Yep, I've got x plus 3 and x plus 3. That's my x plus 3 squared. Negative 11, yes. Minus 11 on the end from combining these two like terms together. Beautiful. Where is this vertex? Negative 3, negative 11, my h and my k. I'm sorry, one more time. Axis of symmetry would be where? Negative 3. Axis of symmetry would be x equals negative 3. How would you describe this transformation from the parent? Left 3 and down 11. Beautiful. I want you guys to do number 3, and that's going to wrap us up for today. Makes sense. You're always welcome to come up. Any of the writing utensils that I have on the desk, you're welcome to help yourself too. You're welcome. did you guys get? Those of you that are finished with this one, what did you get for your finished vertex form? Yep. X minus 5 squared. And then what's our k value on the end? Minus 49. Let's talk about how we get there. So I have my x squared in the upper left. I have the minus 24 out at the back. Minus 5x minus 5x, because we take this and cut it in half so that it can be the same on both sides. That's how we get x minus 5 and x minus 5, or x minus 5 squared. So then I'm going to add something here, but if I add something, I'm going to have to take that exact same thing away again. What do I put down there? 25. How did you get the 25? Yep. We do negative 5 times another negative 5 to get that. And when I combine these two together, I get negative 49. So where is this vertex at? Positive 5 and negative 49. How would you describe the transformation? Right 5 and down 49. What would my axis of symmetry be? X equals 5, yes. Beautiful work. That takes us to the end of what we're covering today. I want to hold off and we'll talk about when A is not 1 tomorrow. Your homework 6, is due on Friday because it has both what we practiced today and problems where A is not 1. The majority of the homework is like today. So you can get most of the questions knocked out. When you're looking at that homework, if you want to get an early start on it, as long as there's no number right after the equal sign, it's a problem you can do. If there's a number after the equal sign, if there's an A value there, wait until we're done tomorrow, okay? Please let me know if you guys have any questions about anything at all.